We are going to be graphing some trigonometric functions, so I'm going to be going through several examples. If you don't have this already handy, you might want to write these things down, this 1, 2, 3, and 4. I'm not going to read it now, but I will reference it as we go along. And then also make sure you know your general shapes of sine and cosine. So there they are. Sine goes through 0, 0. It takes 2 pi to do one full cycle. It goes up to 1 at pi over 2, back down to 0 at pi, to negative 1 at 3 pi over 2, and then back to 0, and that keeps going and going. Cosine goes through 0, 1. So it goes through 1 on the y-axis, down to 0 at pi over 2, down to negative 1 at pi, back up to 0, and back up to 1. So you must know those general shapes. The period of sine and cosine are both normally 2 pi. I just noticed I had this written up here, but what I'm going to do is I'm going to use this idea right here to help us as we talk through there. So those variables are a little bit different, but here we go. So in this number 1, this 4 is multiplied outside the sine. So we're going to do 4 times sine of theta. I'm going to list the phase shift period, amplitude, and vertical shift for each one. And that order, I did that order there important on purpose because that will help us. That's the order in which we think of the things when we graph. So our phase shift, it has to do with C. So I'm looking up at this rectangle here. I'll reference this quite a bit. So that has to do with C, so there is no phase shift. There's nothing added to theta, so none. Period. There's nothing multiplied, so this B has to do with period. So it's just our normal period. It's 2 pi for sine. Amplitude, that's what we do have here. That's 4. And then vertical shift would be the yellow, and that there's nothing added out here, so that's 0. And so what we're going to do is we're just going to start with our x-axis, or actually since we're using theta, it's actually our theta axis, but think of it as your x-axis. There's no phase shift, which means we can just put our y-axis in there and we can start from there. The period's 2 pi. So what we do, there's no phase shift, so our starting point is 0. Then what we do is we take our starting point. This is important. We take our starting point, which is 0. Start writing some of the stuff in here. Starting point is 0 because it didn't shift left or right at all. We add the period to get the end point. And I'll put end point in quotes, and I'll put starting point in quotes because these graphs go on forever. So there's not really a starting point or an ending point, but this is the starting point of the first cycle that we're referring to. So what we'll do is we'll just come down our x-axis a bit, and we'll put a mark, and we will call that 2 pi because we added the period to 0. Oops, 2 pi. So 0 plus 2 pi is 2 pi. And then once we have that first spot there, we're going to split that first cycle into 4 equal parts because that's what we do for trig functions. And oftentimes we label this. This is an easy one. Sometimes if it's not as easy, I won't take the time to label all 4 points here. So We know our starting point is 0. Our ending point is 2 pi. Our amplitude is 4. 1, 2, 3, 4. And we'll go 1, 2, 3, 4. I'm just going to put some guidelines here through 4 and -4. That's the highest and lowest it will go. Vertical shift is 0, so we don't have to worry about that. It doesn't move up or down at all. And so we can graph our function. So we know sine, and if you don't know, you need to learn sine starts at 0, then goes up to the highest point at pi/2 in this case, back down to 0, down to its lowest point, which is -4, back up to 0. And I'm just going to put a couple more points in here. So here's our graph. It should be rounded. Don't make these pointy here at the tops and bottoms. And we should also work our way backward a little bit on our graph. So if you follow the pattern, it will, sorry about that, it will look like this. And that's -pi/2 and -pi. So there is the graph of number 1. Moving to number 2. Y equals 1/2 sine of theta. Well, there's no phase shift. There's nothing added to theta here within there, so there's no phase shift. So we'll put none. Period. Period comes from what's multiplied times made the arrow at the wrong spot. What's multiplied times theta. There's nothing written there, so it's an understood 1. And so it's just its normal. It's 2 pi, because period of sine is usually 2 pi. It's actually, just so we start thinking of it, it's 2 pi over 1, over that number that's right there, which is just 2 pi. Amplitude. Amplitude comes from what's multiplied out here, so the amplitude is 1/2. And the vertical shift would be if there is something added outside of here, and there's not, so there's no vertical shift. So what we do is we're going to draw our x-axis or our theta axis. Since there's no phase shift, we can just draw on our y-axis. That is our starting point. So remember from before, we take our starting point. So since there's no phase shift, the starting point is 0. And then we're going to add the period to get the ending point. Of the first cycle. And so sine, we're graphing sine. Oops, I didn't put this in here. So we're going to put our ending point, which is 2 pi. We're going to split that into 4 equal parts. And again, this is easy to split and to figure out the numbers. This is 1/2 pi. We could also write pi/2. This is 3/2 pi, which is 3 pi/2 either way. We could come back the other direction. This is -1/2 pi, -pi, -3/2 pi, -2 pi. All right, so we have the period in there. We have our starting point and our ending point. We have an amplitude of 1/2, which means we're going to come up to 1/2 and down to 1/2, -1/2. Now we could put this anywhere we want. We can choose where they go on the y-axis. I'm making them pretty close to the x-axis, so we see that this is definitely a shorter or smaller amplitude. Our graph's going to end up going right over our my numbers that I wrote there. the phase shift, there isn't a phase shift, so we don't have, sorry, there is not a vertical shift, so we don't have to worry about that. So now thinking of sine, sine starts at 0. It goes up to its highest point, back down to 0, back down to its lowest point, which is -0.5, back up to 0, and that would continue. And then we can draw a nice smooth graph going through those points. We can work our way backwards following that pattern. And there is the graph of y equals 1/2 sine of theta. I'm going to go ahead and not do 3 and 4. They're going to be very similar, except they're cosine. Well, I lied. We're going to do this because it's cosine, because we haven't done one yet. We'll see one later, I'm sure. But here we go. Maybe we'll work through it a little bit quicker. There is no phase shift because there's nothing added here. There is no extra period. The period is just going to be 2 pi because what's multiplied by theta here, well, it is a 1, so it's 2 pi, the normal period over 1, which is still 2 pi. The amplitude is what's multiplied out front here, so that's 3. And there is nothing added out here, so the vertical shift, there is none. We're at 0. And so we're going to draw in our x or theta axis. There's no phase shift, so we can just draw in our y-axis. So once again, maybe you're getting tired of this, but our starting point, because there's no phase shift, it doesn't move left or right at all, our starting point is at 0 on the x-axis or theta axis. And then we add the period to get our ending point. So we have 0 plus the period, which was 2 pi. 0 plus 2 pi is 2 pi. So we put our ending point somewhere out here. We split that into 4 equal parts. And we can label those. We can go backward and label these. We know our amplitude is 3, so we're going to go up 3 and down 3. We'll draw some guidelines there. Oops, missed the point there. And now, and there's no vertical shift, so we don't move up or down at all. So now we're thinking we're graphing cosine. Now cosine starts up normally at 1 on the y-axis, but since the amplitude is 3, it will start all the way at 3 on the y-axis, come down to 0, come down to -3, back up to 0, back up to 3. We will sketch that in. And then we realize this continues, so we can put a point there. We'll go down, and then we can continue our pattern. I like to put the points in first, and then draw my graph to hit those points. So there's an example of one with cosine. I'm going to go ahead and stop this video now, and then I'll make a part 2, which will deal with the period changing.